human vision captures a fraction of the sun's radiation. The smooth, steady disk visible from Earth is a filtered perception that hides a chaotic and violent reality. The light reaching us today is deceptively old. A single photon generated in the solar core takes anywhere from 10,000 to 170,000 years to navigate the dense plasma of the interior before finally escaping the surface. To bypass the calm of visible light, scientists use the electromagnetic spectrum. By observing different wavelengths, such as extreme ultraviolet, we can resolve the high-energy plasma structures that remain invisible to the naked eye. Relying on non-visible wavelengths allows us to observe the true ferocity of the engine powering our solar system. We begin at the corona, the sun's outermost atmospheric layer. It consists of plasma burning at 1 million Kelvin. Kelvin is an absolute temperature scale used by scientists, where 0 represents the total absence of thermal energy. Total solar eclipses provide a rare opportunity to see this layer without instruments. When the moon blocks the blinding photosphere, the radiant exterior of the corona becomes visible to the human eye. Extreme ultraviolet light reveals even more intense activity. At 20 million Kelvin, solar flares erupt from the sun, spewing immense amounts of electromagnetic radiation into space. These explosions occur when magnetic fields cross and reorganize themselves rapidly. This activity originates from the turbulent motion of the plasma within the star itself, which twists the field lines until they snap and release energy. The environment surrounding the sun is a highly volatile, magnetically charged space that constantly stores and releases immense explosive power. Coronal holes appear as darker, cooler regions where the magnetic field is open. Instead of forming loops that return to the surface, these field lines stretch outward across the solar system, providing a path for solar wind particles to escape. When these escaping winds collide with Earth's magnetosphere, they produce the aurora lights that dance across the polar night skies. In contrast, closed fields create solar prominences. These are planet-sized loops of plasma trapped within magnetic arches that can stretch hundreds of thousands of kilometers into the corona and persist for months. When these magnetic traps fail, the result is a coronal mass ejection. Tightly wound fields snap like an elastic band, firing billions of tons of plasma across the solar system. The sun's magnetic field functions as both a cage and a cannon, generating beautiful prominences while simultaneously launching threats toward Earth's satellites and power grids. Within the transition layer, a shallow layer only 100 kilometers thick, the sun's thermodynamics defy simple logic. The temperature leaps from 8,000 Kelvin at the base to 500,000 Kelvin at the top. Just below this sits the chromosphere, home to features known as spicules. These are jets of plasma 10 kilometers high that shoot upward at speeds of 100 kilometers per second, nearly 300 times the speed of sound. Scientists long debated how these jets escaped the sun's magnetic fields until 2017, when models introduced neutral particles into the equation. Neutral particles are atoms that carry no electric charge and are not directly bound by magnetic field lines. These neutral particles collide with magnetically charged particles, providing the buoyancy needed to lift the plasma and shoot it upward into the atmosphere. These microscopic interactions between neutral and charged particles dictate the large-scale violence of the sun's lower atmosphere. Below the atmosphere lies the photosphere, the sun's perceived surface. Since the star is too hot for solids or gases, this layer is composed entirely of plasma, a mixture of ionized atoms and free electrons, often called the fourth state of matter. Sunspots mark the photosphere as cooler, darker regions where magnetic fields are exceptionally powerful. These cooler spots are the exact locations where the violent solar flares mentioned earlier originate. The photosphere is saturated with solar granules, which are convection cells 1,000 kilometers wide. Hot fluid rises in the center, spreads across the surface, cools, and sinks back down the dark boundaries in a continuous boiling cycle. This relentless boiling thermal engine drives every explosion and loop in the massive atmospheric layers above. Against the scale of this multi-layered plasma engine, the Earth is a small and fragile presence. Features like exploding flares, vast coronal holes, and supersonic spicules remain hidden if we rely solely on our biology to observe the universe. Scientific discovery begins when we look past the limits of visible light to uncover the awe-inspiring, invisible realities of the cosmos.